Hi, I'm Joe James. Welcome to part 5 in my series on quadratic equations. In this video, we're going to learn to use the factoring method to solve quadratic equations. The standard form for our quadratic equation is ax squared plus bx plus c equals 0. So we have a, b, and c here, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So our process is this. It's 4 steps, and it's not that complicated. First, we're going to find all factor pairs of c, which is the constant. Recall we did that in the second video in this series, so if you haven't seen the second video, go back and watch that real quick. It's very simple to figure out the factor pairs for the constant. Next, we're going to pick the pair whose sum is b. In other words, we're going to pick the pair of factors of c that add up to b. Then we're going to rewrite the equation as a product of binomials. So you'll see how this all works in the next example. So here's our problem. Solve by factoring. First, we have to find all factor pairs for 8. So let's see, how many ways can we multiply numbers together to get 8? Well, 1 times 8, and 2 times 4. 3 times anything? No. 4 times 2. Yes, we already did that. So that's all. Plus there's of course the negative versions of these, right? -1 times -8, -2 times -4. We're looking for a pair of these that add up to b, which is, here b is 6, right? b is 6, c is 8. So we found the factor pairs for 8. We're looking for a pair of them that add up to 6, and that's right, 2 and 4 add up to 6. So we found that. 2 of those add up to b. Now we're going to rewrite our equation as a product of binomials. So since this is an x squared term, our product of binomials is going to have an x here and an x here. And it's going to equal 0. Let's see, x plus 2 and x plus 4. X plus 2 and x plus 4. This is a factoring of this quadratic equation. It's basically FOIL in reverse. So if we applied FOIL to this, x times x is x squared. 2 times 4 gives us the constant, which is 8. And then if we multiply 2 times x plus 4 times x, the inner and outer terms, we would get 6x. We could apply FOIL to this and get back to our original quadratic equation. So this is the quadratic equation as a product of binomials. Now we can easily solve this using the zero product property that we also learned in one of the previous videos. So we set x plus 2 equal to 0. Let's do that over here. X plus 2 equals 0. And we subtract 2 from both sides. And we get x equals -2. So that's one solution, and then x plus 4 equals 0. We subtract 4 from both sides, -4, and we get x equals -4. So our solution set is x equals -2, or rather -4, I'll write that first since it's smaller, and -2. So that's our solution set for this quadratic equation. Let's try another one. We're going to do several more because there are different possibilities of whether you have an a term here and so on, and some negative numbers are thrown in. Okay, this one is very similar to the first one we did. So let's find the factor pairs for 15. Let's see, 1 times 15. 2 times anything? No, because 15 is odd. 3 times 5. 4, no. 5 times 3. Okay, now we're back to, so that's it. So 1 times 15 and 3 times 5. Now can we find 2 of these that add up to b, and b is 8? Well, yeah, 5 and 3 add up to 8, right? So we're going to pick these 2 factors, and we have to rewrite the equation as a product of binomials. So x, here we have an x squared term, so it's going to be a little bit different when we have a coefficient in front of this x squared term, but right now we don't. So x plus 3 and x plus 5 is what we're going to write. X plus 3 times x plus 5. So we've rewritten our quadratic equation as a product of binomials using this factor pair that we picked because those add up to 8. So let's just test this. We can apply FOIL. X times x is x squared. The constants multiplied together, 3 times 5, that's 15. And then we add these two x terms. So 5 times x and 3 times x added together make 8x. So that's the first, or rather the outer and the inner terms added together give us 8x. So yeah, this checks out. This is basically FOIL in reverse because if we apply FOIL, we get back to our original equation. So now we just need to solve this for the two values of x. So x plus 3 equals 0. We subtract 3 on both sides. We get x equals negative 3. And x plus 5 equals 0. We subtract 5 on both sides. We get x equals negative 5. So our solution set is negative 3, negative 5. Okay, let's try another one. Now this one's different because we have a negative number here. We have a positive 1. There's an implied 1 here. B is a positive 1. And C is a negative 6. So let's see. When we're looking for factors of 6, well, 1 times 6 equals 6. 2 times 3 equals 6. And are there any other ones? No, that's it. Those are all the factor pairs for 6. However, because of this negative sign here, one of the numbers has to be positive and one of them has to be negative, right? When we multiply a positive and a negative together, we get a negative. So we need one to be positive and one to be negative. And somehow they need to add up to a positive 1. So let's see. If we have a positive 6 and a negative 1, that would give us a positive 5. That doesn't work. If we have a positive negative 1, let's see, negative 2 and a positive 3, that works, doesn't it? Positive 3 and negative 2. So it's really kind of trial and error to figure out which pair of these we can use and which one has to be positive and which one negative. So look, we can rewrite this as a product of binomials where we're going to use a positive 3 and a negative 2. So x plus 3, x minus 2 equals 0. So let's test this. Negative 2 times 3 is negative 6. So the constant works. X times x is x squared. That works. Now let's check out the outer and inner terms, which are the x terms. Negative 2 times x is negative 2x. And 3 times x is 3x. And when we add those together, we get 1x, which is exactly what we have here. So yes, this checks out. So now let's solve for x. We now have a product of binomials. So x plus 3 equals 0. We subtract 3 on both sides. And we get x equals negative 3. And the other one is x minus 2 equals 0. And we're going to add 2 on both sides. And we get x equals 2. So our solution set looks like this. It looks like negative 3, comma 2. Those are our two solutions for this quadratic equation. Okay, here's another one where we have a negative value here. Here we have a negative value for b, and there's still no a. A is 1, essentially. So what are the factor pairs for 9? That's where we're always going to start out. 1 times 9, 3 times 3, and that's about it. We want them both to either be both positive or both negative because 9 is positive. So if they're both negative, that would work. Or if they're both positive, that would work. We need to get a positive 9. However, since b here is negative 6, that kind of clues us that they're probably both going to be negative. If we have to use two negative numbers that add up to negative 6, we can't pick 1 and 9. That would be negative 10, wouldn't it? So negative 3 times negative 3 would multiply out to a positive 9, and negative 3 plus negative 3 would add up to negative 6. So we can use negative 3 times negative 3. So let's rewrite this as x minus 3 times x minus 3. So now we see the negative 3's multiplied together. Those negatives would cancel each other out, and we would get a positive 9, which matches. The x's, you get an x squared, and you'd get a negative 3x and another negative 3x when you multiply out the outside and inside terms. So we would have a negative 6x when we add those together and combine the like terms. So that is what our equation looks like. You could also rewrite this as x minus 3 quantity squared. And when we solve this, there's really only one solution because these are both the same. X minus 3 equals 0. We add 3 to both sides, and we get x equals 3. So we could do the same thing with the other one, but we're also going to get x equals 3. The solution set is really only one value, 3. So that's our whole solution set, just one answer. Now this one is a little bit of a twist because we have an a of 2 here. You see this 2? That's going to throw a curve at us. It's going to be a little more tricky to solve this, but we can still do it. If we have a 2 or a 3 here in front of that x, or a 5 maybe, some prime number, we can deal with it. But when you get a bigger number that has a whole bunch of factors in front of x squared here, then it's going to be too complicated to solve by factoring. So let's figure out factors of 4. Well, we have 1 times 4 and 2 times 2. And now when we rewrite our equation, we're going to rewrite it like this. 2x plus something times x plus something. And we have to pick a pair of these. However, whichever number we put over here on the right side is going to be multiplied by 2. Because if we apply FOIL to this to get back to the original quadratic equation, we're going to be multiplying this 2x times that, and the inside number times that. So our x term is going to be 2x times this plus x times this. So whatever number goes here is going to be doubled and added to this number. And those have to add up to 9x. Okay, so let's see, which number can we double and then add to the other one to get to 9? Well, not 2, right? 2 times 2 would give us 4x. And then if we put a 2 here, we would get another 2x, and so that would add up to 6x. So that doesn't work. But look, if we double this 4, and we add 1 to it, 2 times 4 is 8, add 1 to it is 9. So that gets us there. So in other words, we have to write the 4 here, and the 1 here. This is the only way it works. Then when we multiply it out using FOIL, we see 2x times 4 gives us 8x, and the inside term, this is the other x term, is 1x. And if we add those together, we get 9x. So that's how we can use FOIL to check to make sure this works out. And then, of course, the x terms. 2x times x gives us 2x squared, and 1 times 4 gives us 4. So using FOIL, we just verified that this is correct. Lastly, we just have to solve this. So we factored it. It was a little bit trickier because of that 2, but we got it. Now it's 2x plus 1 equals 0. We subtract 1 from both sides. 2x equals negative 1. And then we divide by 2 on both sides, and we get x equals negative 1/2. And then our other answer is x plus 4 equals 0. And we just subtract 4 on both sides. We get x equals negative 4. So our solution set is going to look, let's write it over here, we can fit it, negative 4, comma, negative 1/2. Okay, let's do one more problem. So you get the hang of this solve by factoring. Okay, here we have a 3x squared. So a is 3. we have a negative 7 over here and a negative 4. So again, this is getting a little more complicated because we're throwing some negative numbers and we also have an a value. So let's just start where we always start. We'll factor the 7, right? 7 is a prime number, so we only have 1 times 7. There's nothing else. And we can see that because this is negative, one of these has to be negative. It's either negative 1 times 7 or negative 7 times 1. So watch, I'll just write negative 1 times 7 or negative 7 times 1. Those are our two choices. We don't just get to pick two that add up to negative 4 because one of them is going to be multiplied by 3. So watch what happens. We're going to have the 3x plus something, or probably minus something, and then x plus something or minus something equals 0. So that way when we apply FOIL, you'll see this first term, 3x times x, gives us 3x squared. And the second terms, we're going to put these two in these two positions here. And those two will multiply out to negative 7. Now we need to figure out how to get this negative 4, knowing that whatever number we put here is going to be multiplied by 3, right? When you apply FOIL to test this, this number there is going to be multiplied by 3x. So let's see, if we put a 1 here, and we put a negative 7 here, does that work? Well, negative 7, this is trial and error, because if this doesn't work, then we have to try 1 over here and negative 7 over here, or we can try negative 1 and 7. So there's actually 4 possibilities, right? There's 2 different pairs of factors, but there's also 2 different positions for them each. So the first one I tried is negative 7 and 1, and let's see, 3x times 1 is going to give us 3x, and then negative 7 times x is going to give us negative 7x. And when we add those together, we're going to get negative 4x. So actually, the first try, I just kind of got lucky. There's 4 different combinations, but I just got lucky in the first pick. That's the right answer here. So x plus 1, x minus 7. That's the minus sign. See, if this didn't work, then we would take the 1 out and the negative 7 out, and we would rearrange them. We would swap positions. And then if that didn't work, we would try negative 1 and positive 7 and try those in both positions. And hopefully one of those works. It multiplies out correctly. So the last step then is to solve this. So 3x minus 7 equals 0. We add 7 to both sides. Plus 7. 3x equals 7. And then we divide by 3 on both sides. We're going to get x equals 7 thirds. And the other one is x plus 1 equals 0. We just subtract 1 on both sides. And x equals negative 1. So our solution set looks like this. Negative 1, comma, 7 thirds. Those are our 2 solutions. I hope this video is helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.